chokers also. Okay. Now here I want to discuss remaining two commutation techniques, that is ClassE commutation and ClassE commutation. Okay. So that you concentrate first, we will start with the ClassE commutation. It is also called complementary commutation. Okay. ClassE commutation. I'll note down this ClassE commutation. It's also called complementary commutation. S is also called complementary commutation. Complementary commutation. Complementary commutation. Okay. Why it is complementary? That I will give the statement based on the operation. First, you draw the circuit for ClassE commutation. This is important for any competitive point of view. Even in GATE exam, based on this concept, already question is problem is faced. Okay. Yes. First, you draw the circuit. This R1. Yes. This R2. Capacitor. This is T1 thyristor, and this is T2 thyristor. T1. This is T2. And the supply voltage is Vf. The supply voltage is Vf. Let this current is I1 and this current is I2. And this current is IT1. This current is IT. Okay. Let's assume that initially there is no charge in the capacitor. With that assumption only, we'll start the operation of this circuit. Assuming that there is no initial charge in the capacitor. Okay. Now, in different cases that I want to explain what is the operation of this circuit. Now see, in case 1, yes, in case 1, that initially T1 is triggered. Initially, the voltage across T1 is Vs, the voltage across T2 is also Vs. Now, we are triggering the T1 thyristor. If T1 is triggered, then if T1 is triggered, if T1 is triggered, what the equivalent circuit you tell me? This is the equivalent circuit. Parallelly note down, don't wait. This is Vs. This R1 capacitor, R2. T1 is triggered means it starts the conduction. Okay. Now, this is R1. Let this current is I1 and this current is I2 and this capacitor. Initially there is no charge in the capacitor. Now this current is IT1. Now there exists two currents through T1 thyristor. There exists two currents through T1 thyristor. One is I1 current, another one is I2 current. Okay. Now slowly the capacitor is charging with a polarity plus minus, with a polarity plus minus Vs. But at the instant of triggering, initially there is no voltage across the capacitor. Okay. Now tell, what is the current through T1? There exists two currents. What is IT1 equal to? One is I1 current, that is I1 plus I2. Then what is IT1, you tell me? IT1 equal to, this is the current through R1 resistor. The supply voltage is Vs. Then how we can write? Vs by R1. This is the current through R2 and C. It's just like RC circuit current. How we can write? Vs by R2 into e power minus 1 by R2C into T. This is current through T1 side. Then what is peak current of this one, you tell me? IT1P equal to, or the peak value of this current, Vs by R1 plus Vs by R2, that equal to Vs into 1 by R1 plus 1 by R2. When this value is peak value, when T equal to 0, then this value is peak value. Vs into 1 by R1 plus 1 by R2. Okay, this is a peak current. Now tell me, slowly the capacitor is charging. Slowly the capacitor is charging with a polarity positive, negative, Vs. The capacitor charged to a maximum voltage of Vs. In this case, after completing this instant, then voltage across T2 is at this instant. What is capacitor voltage? The voltage across T2 is positive voltage only. Still it is not negative voltage. Okay, the voltage across T2 is nothing but a, slowly it is charging means the voltage across T2 is also appears. This is positive and this is negative means then still it is forward voltage only, T2 also. Okay, but this point mainly concentrate. This is IT1 and this is IT1P, peak value. Then this peak value, whenever T equal to 0, then we can get the peak current. But we know that after completing this case, then if capacitor is fully charged, if capacitor is fully charged, if capacitor is fully charged, then what is the I2 current becomes 0. I2 equal to 0. Then only current in the T1 thyristor is, if it is fully charged, there is no current here. The only current is I1, that equal to Vs by R1. Vs by R1. In this case, I want to define what the voltage across the capacitor. Voltage across the capacitor is nothing but a, the capacitor current is flowing like this now. Vs minus this drop. This gives the voltage across the capacitor. Vs minus I2 into R2. Okay. Then Vc equal to Vs minus, what is I2 you written? Vs by R2 into e power minus 1 by R2C into T into R2. R2 cancel. What is Vc equal to? Vs into 1 minus e power minus 1 by R2C into T. Okay, this is the voltage across the capacitor in case 1. Now, like this T1 is conducting. Now, this circuit is ready to turn off T1. If you want to turn off T1 means you can trigger T2. Then only T1 will be turned off. Understood? But at the instant of triggering of T2, the voltage across T2 is positive. This plus minus, this is the voltage across the thyristor, T2 thyristor. That means, this I am explaining as a case 2. case 2 tells. This is case 2. If T2 is triggered, T1 is turn off. T1 is turn off. Okay. If T2 is triggered, T1 is turn off. If T2 is triggered, T1 is turn off. Why? Whenever T2 is triggered, this positive connected here, negative connected here. With this polarity, a negative voltage will appear across T1, then T1 will be turned off. Then what the equivalent you tell me? Whenever T2 is triggered, the equivalent circuit is like this is the equivalent circuit. This is Vs. If T2 is triggered, the equivalent circuit is like this. This is R1 thyristor. T2 is triggered means T1 is turn off. T1 is turn off. Okay, this is a capacitor. And this is R2. Now T2 is conducting. Let this is IT2. Already voltage across capacitor is Vs. Now this is under case 2. Now what the current is passing through T2 thyristor? Again two currents are passing through T2 thyristor. Yes. One is, this is I1 current and this is I2 current. The I2 current is like this. The I1 current is like this. There is a two current. Shall you write like this? What is IT2 equal to? I1 plus I2. Okay. Then what is IT2 equal to? What is I1? Minus plus Vs, minus plus Vs. 2 Vs. That's already there is capacitor voltage. Na? That's a 2 Vs by R1 into, this is current through RC circuit na, e power minus 1 by R1C into T plus this is Vs by R. Okay, this is the T2 instantaneous value of T2 thyristor current. Okay. Now I want peak value of T2 thyristor current. IT to T is equal to, for T equal 0 you can get the peak value. Vs into 2 by R1 plus 1 by R. Okay. Now after completing this interval, after completing this case, it becomes positive, it becomes negative. Then capacitor is completely changes its polarity. If capacitor is completely changing its polarity, if capacitor is completely changing its polarity, then what about the current through this capacitor I1 becomes 0. Then only current I2 equals, the only current is IT2 is equal to Vs by R2. Under this instant, what is the voltage across the capacitor you tell me? In this case, the voltage across the capacitor equal to, I want this voltage minus drop across this one. Vs minus I1 into R1. What is the voltage across the capacitor? Vs minus, what is I1? 2 Vs by R1 into e power minus 1 by R1C into T1, T into R1. R1 cancel. What is the voltage across the capacitor? Vs into 1 minus 2 into e power minus 1 by RC into T. This is the voltage across the capacitor. This is case 2. Then again, now the polarity, after completing this case 2, now the polarity across this capacitor is plus minus. Now the circuit is ready to turn off. This circuit is ready to turn off T2. If you want to turn off T2 means we can trigger the T1. Okay. Now I am giving as a case 3. But point to remember, during the conduction of T2, the voltage across, during the conduction of T2, the voltage across, slowly capacity changing plus minus na. Now plus minus means this plus is connected here, this minus is connected. Then voltage across T1 is positive. So that point to remember. At the instant only, whenever it is triggered, this negative voltage will appear here. Whenever this triggered, this negative voltage will appear here. Okay. Now what I am explaining, if T2 is triggered, if T1 is triggered, if T1 is triggered, now tell me, if T1 is triggered, then T2 is turn off. T2 is turn off. Now what is the equivalent? Whenever T1 is triggered, this positive is connected. This is the polarity. Now this is the polarity. This negative is connected here. Now the polarity is this one. This is negative, this is positive. Now the polarity is, this is positive and this is negative means with this polarity, negative is connected here, positive is connected here, T2 will be turned off. This negative will be connected here. This positive will be connected here. Then T2 will be turned off. Okay. Now T2 is turned off. What is the equivalent circuit? Now which device is conducting? T1. What is the polarity after completing case 2? Plus minus. This is R1. This is I1. Now T1 is conducting. This is R2. This is I2. This capacity. T2 is turned off. This is here. Now again there is a two currents through T1 thyristor. There is a two currents through the T1 thyristor. One is I1 current, another one is I2 current. Then what is IT1 equal to? There is a two currents through T1 thyristor. That is Vs by R1 plus minus plus minus plus 2Vs. 2Vs by R2 into e power minus 1 by R2C into T. Then what is IT1 equal to? That is IT1. Then what is IT1 P value? Take Vs is common, 1 by R1 plus 2 by R2. Okay. After completing this case, then it becomes positive, this becomes negative. Slowly the capacitor is changing its polarity. Then if capacitor is completely reversing its polarity, if the capacitor is completely reversing its polarity, then what is the voltage you tell me? Reversing its polarity. Then voltage is how much? Voltage across the capacitor. Sorry. If I completing reverse, this becomes positive and this becomes negative, then I2 equal to 0. Then I2 equal to 0. What is I1? Only Vs by R. Then in this case, what is the voltage across the capacitor? Vs minus, this is like this na, I2 into R2. Then what is Vc equal to? Take Vs is common, 1 minus 2 into e power minus 1 by R2C into T. Okay, this is the voltage across the capacitor if T1 is conducting. Clear? Okay. This about different cases I am explaining. Okay. Now with this knowledge, now we'll see how to draw the waveform. With this knowledge, what is the waveforms for class C commutation that you concentrate. But one observation here, if T1 is on, T2 is off. If T2 is on, T1 is off. That means turn on of one thyristor will turn off the another thyristor. Turn on of one thyristor will turn off the another thyristor in this commutation. That's why it is called complementary commutation. Turn on of one thyristor will turn off the another thyristor. That's why name is given as a complementary commutation. Okay. Now see how to draw the waveform. Concentrate. different cases I am drawing the waveform. Initially, let T1 is triggered. Is a triggering pulse is applied to T1. If T1 is triggered, then this is the current through T1. This is a current waveform. Okay, this T1 current wave. Initially, what is the current in T1? The peak current is Vs into 1 by R1 plus 1 by R2. Okay. After completely discharging, changing its polarity, then only current, this one is, this is Vs by R1. Okay. Then this is for T1 is triggered. This triggering pulse is T1. Now at this instant, if we trigger the T2, if the triggering pulse is applied to T2, IZ2. Okay. Now if triggering pulse is applied to T2, for the current, this is IT1 waveform. Now I am drawing IT2 waveform. Then if T2 is conducting, okay, then what is the peak current here? Vs into 1 by R1 plus, sorry, 2 by R1 plus 1 by R2. This is according to case 2. Vs into 2 by R1 plus 1 by R2. Then after completely discharging, then what this current only? Vs by R2. Again, if T3 is triggered, sorry, if T1 is triggered, again triggering pulse is applied to T1. This is IZ1 pulse. Then again current is like this. This current is Vs by R1. But this peak current is Vs into 1 by R1 plus 2 by R2. This is according to case 3. Vs into 1 by R1 plus 2 by R2. 1 by R1 plus 2 by R2. Okay. Like this we can get the T1, T2 current waveform. Then how to draw the voltage across the capacitor? If I am drawing VC waveform first. Okay. If T1 is triggered, okay, slowly the capacitor charged to a voltage of Vs. If T1 is triggered, slowly the capacitor charged to a voltage of Vs. Once it is completely charged, then only current is Vs by R1. It acts as open circuit, then I2 becomes 0, only I1 current it presents. Okay, this is capacitor. Now if T2 is triggered, if T2 is triggered means, now what happens? If T2 is triggered, the capacitor is changing its polarity. This plus Vs to minus Vs, it is changing. Plus Vs to minus Vs, it is changing. Once it is charging from plus Vs to minus Vs, like this it is charging. Here T2 is triggered now. Once it is charged to plus Vs to minus Vs, the voltage is This is minus Vs. The only current is Vs by 2. That is I1 becomes 0. Okay, once it is completely charged. Plus Vs2 minus Vs. Like this. Now again, which is triggered here? T1 is triggered. Again changing its polarity. Once it is completely charged, then it is charged to Vs. Then only current is Vs by R1. This is the voltage across the capacitor. Tell. This is T. This is T. Now I am drawing the voltage across T1 thyristor. This is VT1. And voltage across T2 thyristor. Tell. With respect to T1 thyristor and T2 thyristor, I am drawing the waveform. Here T1 is conducting. The voltage across T1 is 0. Okay, once T1 is conducting, the voltage across T1 equal to 0. Up to this, T1 is conducting. Whenever T2 is triggered, suddenly this voltage, T2 is triggered, suddenly this voltage will appear across. Okay, a reverse voltage will appear across T1. Then it charged to a voltage of, okay, a reverse voltage will appear across T1. Then slowly it charged to a voltage of Vs. Again it charged to plus Vs. If T2 is triggered, negative voltage will appear across T1. T1 will be turn off. But capacitor is slowly charged, changing its polarity now. Then again changing its polarity. This is the instant. This time is nothing but a circuit turn off time of T1. Okay. Again here T1 is triggered now at this instant. Here T1 is triggered. If T1 is triggered, I am drawing the voltage across T2. Up to this, the voltage across T2 is forward voltage. This is forward voltage. Slowly the voltage across T2 is forward voltage. Because capacitor is charging. Here T2 is triggered now. T2 is conducting means the voltage across T2 is 0. Here T1 is triggered means that voltage will appear. A reverse voltage appear across T1. A reverse voltage will appear across T1. Then slowly it is charging to a voltage of Vs. And this circuit turn off time equal to Tc2. Okay. Okay, this about voltage across VT1, VT2 voltage across the capacitor, IT1 current and IT2 current. Clear? Okay, concentrate. Now tell me. Now I want to find from these waveforms, I want to find circuit turn off time of T1 and circuit turn off time of T2. Then how to calculate circuit turn off time of T1 and circuit turn off time of T2? Okay, you take after case 2 only you can consider. Take this one from this instant. This at omega t equal to Tc1. Sorry, at t equal, this is T axis na? Sorry, this is T axis. At t equal to Tc1, what is Vc? 0. At t equal to Tc1, Vc equal to 0. What is the voltage across the capacitor? You consider after case 2 only. Sorry, you consider from case 2 instant. What is the voltage across the capacitor? Vs into, here we want with respect to T1 thyristor. That's why you take the equation of voltage across the capacitor with respect to R1. With respect to R1 means that you see the case 2, this one. That is Vs into 1 minus e power 1 minus 2 into e power minus 1 by R1c into Tc1 at t equal to Tc1. Because why I taken this equation means with respect to T1 thyristor I am defining this one. Okay. Then Vc equal to 0 means 1 minus 2 into e power minus 1 by Rc into T1. That is 1 equal to 2 into e power minus 1 by Rc into T1. Then from this you solve this one. This is TC1. Take natural logarithm on both sides. By simplifying this, what we can get? Then circuit turn off time TC1 equal to. Then what is e power minus 1 by R1C into TC1 equal to 1 by 2. Then minus 1 by R1C into TC1 equal to ln of 1 by 2. Then what is TC1 by R1C equal to ln of 2. This negative sign it becomes then 2 power minus 1, that is you can get. Then what is TC1 equal to R1C into ln of 2. This also equal to 0.693 into R1C. This is the circuit turn off time of T1 thyristor. Similarly, you want to calculate what is the circuit turn off time of T2. Then at T equal to TC2. At T equal to TC2 also, what is the capacitor voltage? 0. Then you take this equation because you want with respect to T2 thyristor. Then we can equate that is Vc equal to Vs into 1 minus 2 into e power minus 1 by R2C into TC2. This is equal to 0. Then similarly you can solve. Then what you can get? TC2 equal to R2C into ln of 2. That is 0.693 into R2C. Okay, this is about what is the circuit turn off time of T2 thyristor. Okay, this in detail about what exactly class C commutation. Okay, then the final summary I am writing here. Final summary. What is the IT1P equal to peak current through the thyristor? You take from case 2 onwards, not at starting, case 2 onwards you take. From this instant you take. Then Vs into 1 by R1 plus 2 by R2. That is what is IT2P equal to peak current through the T2 thyristor? Vs into 2 by R1 plus 1 by R2. What is the circuit turn off time of T1 thyristor? R1C into ln of 2, that equal to 0.693 into R1C. What is the circuit turn off time TC2 equal to R2C into ln of 2, that is 0.693 into R2C. Okay. One for example, if R1 equal to R2 equal to R, if R1 equal to R2 equal to R, then what is the peak value of current? IT1P equal to then 1 by R plus 2 by R. Then what we can get? 3 by R into Vs. 3 by R into Vs. That is IT2P. Both are equal. Then what is TC1 equal to TC2 equal to RC into ln of 2, that is 0.693 RC. These are the special cases. We know that in this commutation, turn on of one thyristor will turn off the another thyristor. That's the reason why it is also called which commutation? Complementary commutation. That is turn on of one thyristor, turn on of one thyristor will turn off the another thyristor. Will turn off the another thyristor. Will turn off the another thyristor. That's why it is called complementary commutation. Thyristor. Then what is the application of class C commutation? Application. The application of class C commutation is one is in parallel inverter we can use parallel inverter. The another one is in current source inverter also we can use this class C commutation or complementary commutation. This in detail about class C commutation that you consider. This I am solving. Similarly, you can apply these steps, then we can get this one. R3C into ln of 2, that is 0.693 R2C. This is circuit turn off time of T2. Okay, this about class C commutation. Then in the commutation technique, the last one is you concentrate on class C commutation or external pulse commutation. That is only theory concept. Yes, this over that you will see class C commutation or external pulse commutation. ClassE commutation. Okay, or it is also called external pulse commutation. External pulse commutation. Okay. Now, what is the circuit we are using for ClassE commutation? That you will see. This is main thyristor. T1 is main thyristor. Let it is supplying the power to the resistive load. This is R. This current is I0 is load current. Now, to turn off this thyristor, we are using external commutation circuit. This is the circuit is used to turn off this thyristor. This L, C, this T2 thyristor, this is T3. This is a commutation circuit for ClassE or external pulse commutation. Now see how this ClassE commutation or external pulse commutation. This total circuit is nothing but a commutation circuit. This total is commutation circuit. Commutation circuit. To turn off this thyristor, we are using this circuit. Now I want to explain how this circuit will turn off this thyristor. This thyristor. Okay. Initially I trigger T1 thyristor. Here the numbering I given, notation is given T1, T2, T3 like this. Why I am giving this notation? This notation is followed according to sequence of triggering. First we can trigger this, next you trigger this, next you can trigger this, then it is nothing but a. That's why I am giving numbering like this. Okay. T1 is the main thyristor, T2, T3 is the commutating thyristor. That point also you remember. Now first what I can do means I will trigger the T1 thyristor. Still T2 and T3, this circuit is not activated. Now whenever T1 is triggered, now it's applying the current to the load. It's applying the current to the load. But device is the thyristor, supply is DC, then you don't allow the continuous conduction. If you want to control the power means, you can make on and off. Here we don't have any AC supply. That's the reason why to turn off this T1 thyristor compulsory you can use some external circuit. This is external circuit we are using. Okay. First this T1 thyristor will supplying the power to the load. Then after some time you want to turn off this T1 thyristor. Now tell me. To turn off this T1 thyristor, first what I can do means I will trigger the T2 thyristor. Still it is conducting. If T2 is triggered, suddenly it will not turn off. But this process is started. Some process is started here to turn off T1. Whenever T2 is activated, process will be started. Okay. Now, whenever T2 is triggered, now it is conducting in this circuit. A T2 is conducting like this. A T2 is conducting which circuit? LC circuit. What is the supply voltage we are giving? E supply voltage. E is the supply voltage. External voltage we are giving. Okay. Now, whenever T2 is conducting in LC circuit, we are assuming that there is no initial charge in the capacitor. Without initial charge in LC circuit, the capacitor charged to a voltage of 2 times of supply voltage. It charged to a voltage of 2 times of supply voltage. Now maximum it charging the voltage of 2E. Whenever capacitor charged a maximum voltage of 2E, at this the voltage is 2E and at this the voltage is E. Then automatically T2 will be reverse bias, then T2 will be commutated. T2 will be turned off. That means in LC circuit, capacitor charged to a maximum voltage of 2E. Whenever capacitor charged to a voltage of 2E, then T2 will be turned off. Now the circuit is ready to turn off T1. Based on our requirement, if you want to turn off this T1 means, then we can trigger the T3 thyristor. Then automatically T1 will be turned off. Then how it is possible? Sir, if T3 is triggered, how the T1 will be turned off? Now, whenever T3 is triggered, this voltage will connected here. Plus minus 2E voltage is connected here. Now, what is the voltage at cathode? 2E voltage. What is the voltage at anode? Voltage at anode, this is Vs. Now what is the voltage across T1? Voltage across T1 is now is Vs minus 2E. But you know that 2E is greater than Vs. If 2E is greater than Vs means then voltage across T1 thyristor is negative. If voltage across T1 thyristor is negative, then T1 will be turn off. T1 is turn off. Okay, this type of commutation is called external pulse commutation. How this circuit will be turn off T1 thyristor? First what I can do? First we can trigger the T1 thyristor. Now it's supplying the power to the load. After some time if you want to turn off T1 means, then you can trigger the T2. Whenever T2 is triggered, now this T2 thyristor is conducting in which circuit? LC circuit. Then in LC circuit, capacitor charged to a maximum voltage of 2E. Now after capacitor charged to a maximum voltage of 2E, then automatically T2 will be turned off. Now the circuit is ready to turn off T1. Then in order to turn off T1 means you can trigger the T3 thyristor. Whenever T3 thyristor is triggered, this plus minus 2E voltage, this 2E voltage will appear here. Cathode voltage is 2E, anode voltage is Vs. Then the resultant voltage across T1 is Vs minus 2E. Then Vt1 is negative. Then thyristor will be turned off. That means this type of commutation is nothing but a external pulse commutation or class E commutation. Because by using some external voltage we are turn off the thyristor. The only point to remember in this commutation technique, in this commutation capacitor charged to a maximum voltage of 2E. At the instant of triggering of T1 thyristor, at the instant of triggering of T3 thyristor, the voltage across T1 is Vs minus 2E. These 2 points you remember. That means in this commutation, capacitor charged to a maximum voltage of 2E. Capacitor charged to a maximum voltage of 2E. Maximum voltage of 2E. The another point to remember, at the instant of triggering of T3, at the instant of triggering of T3, voltage across T1 is Vs minus 2E. Okay, these 2 points to remember. And T2 thyristor is commutated because of LC circuit. Whenever this capacitor voltage is greater than the E voltage, then T2 thyristor will be commutated. Okay, these points you remember with respect to class E commutation. With this, what is class C commutation and class C commutation is completed. All the commutation methods completed. In the discussion of commutation methods in power semiconductor devices, I given some introduction to the forced commutation methods and load commutation methods. But in the discussion of the choppers, class A commutation in detail I explained. Class B is completed, class D is completed, class C and class E is also completed. What about class F commutation? At the starting only I discussed in the power semiconductor devices. In commutation methods, in detail about class F commutation or natural commutation, I already discussed. With this, types of choppers based on the commutation and forced commutation method, load commutation method is also completed. But in this chopper, one small concept, SMPS. But in GATE point of view, we don't have any syllabus on SMPS till now. But we may expect. That's the reason why I don't want to give derivations all these in SMPS. Just I will. What is the purpose of using SMPS? What are the different types of SMPS circuits? Then how to write the formulas? That only I want to discuss. Okay. This about in detail about class C commutation and class C commutation. Okay. The next session will continue. Okay.